Hello all, I am Dr. Rizvi and this is part 1 of our video on shear force and bending moment. And in this video we will discuss definition of beam, classification of beam, definition of shear force and bending moment and their sign convention. So let us start with definition of beam. Beam is basically a structural member that is acted upon by external forces or external loads, let they be W1, W2, W3, and these loads act at right angle to the axis of the beam. This is the basic definition of beam. Now let us discuss the classification of beam. Beam is basically classified into 5 types. The first one is simply supported beam. As the name suggests, simply supported beam has two free ends and both these free ends are freely held on two supports. These are the free ends of the beam and it is acted upon by loads like this W1, W2, W3. The second type of beam is cantilever beam. Cantilever beam has one end fixed and its other end is free. This is the fixed end and this is the free end of the beam and it is acted upon by a load like this. The third type of beam is overhanging beam. As the name suggests, its one free end is not supported and it lie outside the support. So this is the overhanging part of the beam and these are the two supports and load will act like this on the beam. So you can draw the diagram of overhanging beam like this. The third type of beam, the fourth type of beam is fixed beam. Like cantilever, it has one end fixed and it has both the end fixed and load act like this on the beam. And lastly, the fifth type is continuous beam. In continuous beam, the beam has more than two supports. It is similar to simply supported beam, but here there are more than two support to the beam. So these are the basic 5 classification of beam. Now let us discuss shear force and bending moment. Let us draw a beam, a simply supported beam having two supports. So the two reactions are R1 and R2 at the support and it is acted upon by some loads W1, W2, W3. And if we cut some section X on the beam at a distance of small x from any of the support, So when a beam which is in equilibrium is cut into some section X and the beam to the left of the section remains in equilibrium, then some force must act at the section to balance the forces acting on the beam. So, to balance these forces that are acting on the beam towards the left of the section, there must be some force that is acting at the section, and this force must be tangential to this section X. This force is known as shear force. At this point, some force that will be acting here will be shear force. Prior to cutting, this force would be provided by the adjacent material, that is this section. If this section is not cut prior to cutting, these forces will be balanced by these two forces that are acting towards the right of the section. Hence, there will be a shearing force at the section and it is tangential to the section. Now talking about the bending moment. When we consider the material to be in equilibrium to the left of the section, and it follows that there can be no resultant moment to the left of the section. So any moment produced by the forces acting on the beam must be balanced by an equal and opposite moment produced by the internal forces acting on the beam. This is the bending moment at that section. If we are cutting this section left hand side and we are drawing it here, this is reaction R1, this is force W1, load W1, and this is load W2, and at this point we have cut the section. So at this point some bending moment will be acting to balance the moment of these forces. So this bending moment is acted at this point at the section. Now we will discuss the sign convention of shear force and bending moment. For the sign convention of shear force sign convention, when we cut some section of the beam and if the forces are acting upward on the left hand side of the section and downwards at the right hand side of the section, these forces are considered as positive. And when we cut some section on the beam and the forces are acting downward toward the left of the section and upward toward the right of the section, these forces are considered as negative. This is the sign convention for shear force. Now for bending moment, the beam may have hogging or sagging. That is, the beam will bend like this or the beam will bend like this. This is hogging condition, and in this case the moment will be acting downward and this is considered as negative. While in sagging condition the beam is bent upward, sagging, and this will be considered as positive. So in this video we have discussed definition of beam, classification of beam, definition of shear force and bending moment, and sign convention of shear force and bending moment. Thank you.